Assalamu alaikum, hello everyone, and welcome back to the good stuff. Today we are covering the topic 4 in chemistry form 2, that is salts. Without further ado, let's dive straight into it. Our topic, salts. What is a salt? A salt is a compound that is formed when the replaceable hydrogen ions of an acid are fully or partially replaced by a metal or ammonium ions. What do I mean by this? We saw acids such as hydrochloric acid, sulfuric acid, nitric acid. Let's take the example of hydrochloric acid. HCl has replaceable hydrogen ions. When these hydrogen ions are fully or partially replaced by a metal or ammonium ions, a metal such as sodium. So if this hydrogen ion is partially replaced by sodium, sodium replaces hydrogen to form sodium chloride. Sodium chloride is an example of a salt. Another example is magnesium sulfate. So let's say sulfuric acid, H2SO4. When this hydrogen is replaced by magnesium to form magnesium sulfate, this is another example of a salt. So we have four types of salts in chemistry. We have the normal salt, the acid salt, the basic salt, and the double salt. First, we look at the normal salts. These are salts that do not contain replaceable hydrogen ions. In the salt, in the compound, they lack replaceable hydrogen ions, such as sodium nitrate. As you can see, in sodium nitrate there are no replaceable hydrogen ions, and in potassium sulfate there are also no replaceable hydrogen ions. Exceptions are sulfites and carbonates, which are basic. Now, why are sulfites and carbonates basic? Are not normal salts? Because they are basic. But normal salts have a pH of 7. They form neutral solutions with a pH of 7. Neutral solutions have a pH of 7. Generally, they are group 1 and 2 nitrites, sulfates, phosphates, and chlorides. For example, group 1 and 2 we know sodium, potassium, lithium, and group 2 magnesium, calcium, and helium. So, but we don't look at helium because it is not a metal, neither is it ammonium. So we look at nitrates, sulfates, phosphates, and chlorides of group 1 and 2, which are normal salts. For example, a phosphate, let's say lithium phosphate. Lithium phosphate. This is an example of a normal salt. When they are dissolved in water, they form neutral solutions with a pH of 7. Another example of chloride, calcium chloride. Calcium chloride. Group 2 is calcium and chloride, so this is another normal salt. Salt number 2 is acid salt. The second type of salt is acid salt. These are salts that contain replaceable hydrogen ions. They form acidic solutions in water with a pH of 4 to 6, hence they are weakly acidic. And exceptions are hydrogen carbonates, which are basic with a pH of 10. So example of acid salts containing hydrogen ions are sodium hydrogen sulfate, we have potassium hydrogen sulfate, so on and so forth. Our third salt is basic salt. Basic salt contain replaceable hydroxide ions. So we saw acid salt contain replaceable hydrogen ions, but basic salt contain replaceable hydroxide ions. They form basic solutions in water when dissolved, e.g. sodium hydroxide, potassium hydroxide, and magnesium hydroxide. Our last type of salt is double salt. This is a salt with more than one anion or cation. We have the double salt. Salt with more than one anion or cation. Examples are sodium carbonate, e.g. sodium carbonate dot sodium hydrogen carbonate dot water. How is this a double salt? This is a double salt because it contains more than one anion, more than one negatively charged ion. How? We have sodium ion here and carbonate ion here. We have another sodium ion but a hydrogen carbonate. Hydrogen carbonate is negatively charged. So we have two anions, one anion and two anions in the same salt. Hence this salt is called a double salt. Another example is hydrated ion hydrated potassium aluminium sulfate. Hydrated potassium aluminium sulfate. We have K A L into brackets SO4 dot 12H2O. So you don't have to remember the formulae of these salts, but when you are told to identify why is it a double salt, because we have one positively charged ion, a cation, which is potassium, and we have another which is aluminium. So when there are more than one anion or cation, the salt is said to be called a double salt. Our next subtopic is solubility of salts. So a salt can be soluble, insoluble or slightly soluble. The following rules will help us to know which salts are soluble, which are insoluble and which are slightly soluble, so that we can have guidelines on how to prepare the different kinds of salts. So number one, all nitrates are soluble. All nitrates, all metal nitrates and all ammonium nitrates are soluble in water. All hydrogen carbonates are also soluble in water, all of them with no exception. So sodium nitrate, potassium nitrate, silver nitrate, barium nitrate, lead nitrate, all of them are soluble. All hydrogen carbonates are soluble. All chlorides are soluble except lead chloride and silver chloride. When you see the word except, these two are insoluble. If all are soluble except lead chloride and silver chloride, means lead chloride and silver chloride are insoluble in water. Hence, they have a different method of preparing insoluble salts. Another is all sulfates and sulfides are soluble except lead sulfate, barium sulfate and calcium sulfate. These three are insoluble, while calcium sulfate is slightly soluble because it is a group 2. All sulfates and sulfides are soluble except lead sulfate, barium sulfate and calcium sulfate. Now these are for sulfate. I have not written this, but the same applies for sulfides. Lead sulfide, barium sulfite, calcium sulfite are also insoluble. Same for lead sulfate, barium sulfate and calcium sulfate. All carbonates, not all carbonates, oxides, hydroxide and sulfides are insoluble except group 1 and ammonium. So all group 1 salts are soluble, even if there are oxides, even if there are carbonates, all of them are soluble. But group 2, group 3, they are insoluble. For example, magnesium carbonate, MgCO3, is this a soluble salt or an insoluble salt? It is an insoluble salt. Why? It is a carbonate. However, sodium carbonate, is it a soluble salt or an insoluble salt? It is a soluble salt. Why? Because it is a carbonate but it is a group 1. Another example, ammonium hydroxide, NH4OH. Is this a soluble salt or an insoluble salt? Ammonium hydroxide is a soluble salt. Why? However, even if hydroxides are insoluble, ammonium salts are soluble and group 1 hydroxides are soluble. So for carbonates, oxides, hydroxides and sulfides, they are insoluble except group 1 and ammonium. So group 1 and ammonium, carbonates, hydroxides, sulfides and oxides are soluble in water. So the solubility of salts will give us the preparation. What is the application of solubility of salts? Application of solubility of salts is what will give us how to prepare the following salts. Methods of preparation of salts. Now, the methods of preparing salts depend largely or highly on whether a salt is soluble or not, or insoluble. We have different methods of preparing soluble salts and different for preparing insoluble salts. So we will start with preparation of soluble salts. These preparation methods mainly involve crystallization, and it involves the following methods. We have 5 to 6 methods. The first one is reaction of an acid and a metal. These are preparing soluble salts. So reaction of an acid and a metal, it is used to prepare salts of fairly reactive metals such as magnesium and zinc. For example, zinc reacts with dilute sulfuric acid to form zinc sulfate and hydrogen gas. Now the definition, the meaning of a salt, a compound in which the replaceable hydrogen ions are partially or fully replaced by metal or ammonium ions. This is what will give you how a salt is formed. So the zinc metal ions replace the hydrogen in the acid to form zinc sulfate and hydrogen gas. As we learned, metal plus acid is salt plus hydrogen gas. Another example is magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen gas. So the magnesium ions Mg2 plus replace the hydrogen ions, two hydrogen ions to form magnesium chloride plus hydrogen gas. That is the first method of preparing soluble salts. The second method is reaction of a metal oxide and an acid. So these are methods of preparing salts. The second method of preparing soluble salts is reaction of a metal oxide and an acid. So metal oxides are oxides of sodium, magnesium, aluminium, copper and calcium react with acids to form salts and water. We learned in a preparation of in a previous topic that oxides react with acids to form salt and water. So copper 2 oxide reacts with dilute hydrochloric acid to form copper 2 sulfate and water. So the copper in copper 2 oxide replaces the hydrogen in H2SO4 to form copper 2 sulfate, and the hydrogen combines with oxygen to form water. We repeat, the copper ions replace the hydrogen ions in the acid to form copper 2 sulfate. The copper takes place of hydrogen to form copper 2 sulfate, and the two hydrogens that are left, they combine with the one left by copper, the oxygen left by copper, to form water. Another example, aluminium oxide reacts with hydrochloric acid to form aluminium chloride and water. So the aluminium ions in aluminium oxide replace the hydrogen ions in the HCl to form aluminium chloride, and the hydrogen combine with oxygen to form water. That is reacting a metal oxide and an acid. Another way of preparing soluble salt is reaction between a metal carbonate and an acid. So that was a metal oxide and an acid. This is a metal carbonate and an acid, and the products are different. In a metal oxide and an acid, a salt and water is formed. However, in a metal carbonate and an acid, salt, carbon dioxide and water is formed. So metal carbonates are salts. They react with acids to form soluble salt, water and carbon dioxide gas. For example, calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon dioxide and water. So the calcium ions in calcium carbonate replace the hydrogen ions in the acid to form calcium chloride, and the carbonate form carbon dioxide, and H reacts with oxygen to form water. Another method of preparing soluble salts is neutralization reaction. What is a neutralization reaction? It is a reaction in which an acid reacts with an alkali. What is an alkali? An alkali is a soluble base. So reaction between an acid and alkali produces neutral solution with a pH of 7. For example, sodium chloride. Normal salts are mostly prepared by neutralization reaction because normal salts are neutral, hence prepared by neutralization. Sodium chloride is prepared by reacting sodium hydroxide and hydrochloric acid. So sodium hydroxide reacts with hydrochloric acid to form sodium chloride and water. Sodium replaces the sodium ions in hydroxide. Now this is a basic salt. This is a base. This is an acid. So the sodium ions replaces the hydrogen to form sodium chloride, and the H2, the hydrogen which is left, combines with the hydrogen and oxygen to form water. So the last method of preparing soluble salts is reaction of acids with metal hydrogen carbonates. For example, sodium hydrogen carbonate reacts with hydrochloric acid to form sodium chloride. The sodium ions replace hydrogen ions to form sodium chloride, carbon dioxide and water. We go to preparation of insoluble salts. Insoluble salts are prepared by methods that mainly involve precipitation or double decomposition. Precipitation is also called double decomposition. What does precipitation involve? Precipitation involves two soluble salts reacting or combining to form a soluble salt and an insoluble salt. There is exchange of ions. The soluble salt remains in the solution. So when there is a soluble salt and an insoluble salt, the insoluble salt does not dissolve, but the soluble salt dissolves in the solution while the insoluble salt is filtered out. So the process involved in the preparation of insoluble salts is mainly filtration. The precipitate is washed with distilled water and dried between two filter papers. For example, preparation of zinc carbonate. Preparation of zinc carbonate. How is zinc carbonate prepared? Zinc carbonate is prepared using sodium carbonate and zinc nitrate. What does this involve? This involves direct exchange of ions. So sodium carbonate reacts with zinc nitrate to form. Now the sodium combines with the nitrate of zinc and the zinc combines with carbonate of the sodium. So this will form sodium nitrate plus zinc carbonate. Now note, the zinc carbonate is an insoluble salt, so it is a solid. It is a solid, while the sodium nitrate is soluble, so it is aqueous. The zinc nitrate here was aqueous because it is soluble, and sodium carbonate was also soluble. So zinc carbonate, as we saw, all carbonates are insoluble except group 1 and ammonium. But zinc is not a group 1, neither is ammonium, so it is an insoluble salt. So sodium will combine with the nitrate of zinc, and the zinc will combine with the carbonate of sodium to form sodium nitrate and zinc carbonate. There is direct exchange of ions. So two soluble salts. Sodium carbonate is soluble. Zinc nitrate, all nitrates are soluble, so zinc nitrate is also soluble. But when these two soluble salts combine, they form a soluble salt and an insoluble salt, which involves precipitation or the double decomposition. Another example is preparation of silver chloride. Let's rub this up. Preparation of silver chloride. How is silver chloride prepared? Silver chloride is an insoluble salt, isn't it? Silver is valency 1. Silver is valency 1. So silver chloride is an insoluble salt. But how is it prepared? It is prepared using two soluble salts. For example, take any soluble salt of silver. Let's say silver nitrate, and a chloride of any soluble salt, which is, for example, sodium chloride. We can use sodium in all the examples because it is group 1 and all group 1 salts are soluble. So sodium chloride, it is a soluble chloride, and silver nitrate is soluble. These two soluble salts combine. To form a soluble salt and an insoluble salt. So sodium reacts with nitrate and silver combines with chloride to form sodium nitrate. Sodium chloride reacts with silver nitrate to form sodium reacts with nitrate to form sodium nitrate, and silver reacts with the chloride of sodium to form silver chloride. However, as these three are aqueous, silver chloride is insoluble, hence it is a solid. Silver chloride is then filtered out of the solution through filtration and washed in distilled water and dried between two filter papers. Another way of preparing insoluble salts is direct synthesis. Direct synthesis is the combination of elements directly that form the salt. For example, how do you form sodium chloride? you can react the elements that are constituting this salt, which are sodium and chlorine. So when you place a piece of metal in a deflagrating spoon in a gas chamber of chlorine, you can react sodium directly with chlorine to form sodium chloride. This is direct synthesis, where two elements are combining to form the salt directly. But in double decomposition or in precipitation, two soluble salts combine to form insoluble salts. They exchange each other's ion, and the insoluble salt is then filtered out of the solution. The insoluble salt is then dried between two filter papers, is then washed in distilled water and dried between two filter papers. I repeat, the insoluble salt is then washed in distilled water and dried between two filter papers. Our next subtopic is effect of heat on salts. So when salts are heated, they undergo thermal decomposition to form new substances and give out new products. So we will look at effect of heat on various salts: carbonates, nitrates, sulfates and hydrogen carbonates. When heated, some salts form new substances and undergo thermal decomposition. The first one is nitrates. So when group 1 nitrates are heated, they decompose to give their corresponding nitrites and oxygen gas. The second one is nitrates of calcium, magnesium, lead, zinc and copper decompose to give the metal oxides, nitrogen 4 oxides and oxygen. Nitrates of silver and mercury give the metal, nitrogen 4 oxide and oxygen gas because they are less reactive. So we write the equations for the following reactions. When nitrates of calcium, so let's say calcium nitrate decomposes, this is heat, decomposes, thermal decomposition, it is directly heated to form calcium, to form the metal oxide, so calcium oxide plus nitrogen 4 oxide. How is nitrogen 4 oxide written? Nitrogen 4, nitrogen valency 2, oxygen valency 2, 2 cross, 4 cross, this is N, 2O4, 2 goes with 1 and 4, 2, this is NO2. So nitrogen 4 oxide is written as NO2. Nitrates of calcium, magnesium, lead, zinc decompose to give metal oxides, nitrogen 4 oxide and oxygen because they are moderately reactive. Calcium nitrate decomposes to give calcium oxide plus nitrogen 4 oxide plus oxygen gas. How do you balance this equation? With a 2 and a 4. When group 1 nitrates decompose, they give corresponding nitrites and oxygen. So group 1 nitrate, let's say sodium, when heated, it decomposes to give the nitrite of sodium. So sodium nitrate plus oxygen gas. The nitrates of silver and mercury give the metal, NO2 and oxygen because they are less reactive. So the nitrate of silver, silver nitrate, AgNO3, decomposes to give the metal silver, this is heat, plus nitrogen 4 oxide plus oxygen. Mind the symbols. This is how the equation is balanced. So these are the thermal decompositions of nitrates. We have carbonates also. Effect of heat on carbonates. The group 1 carbonates are stable. These do not decompose when heated. They only lose water of crystallization. So sodium carbonate, potassium carbonate, group 1 carbonates do not decompose. They lose their water of crystallization. The observations when a group 1 carbonate is heated is 1. White solid changes to white powder, white crystals changes to white powder, and colorless liquid droplets formed on the cooler parts of the test tube. This is white crystals. White crystals change to white powder because they lose water of crystallization, and colorless liquid droplets formed on the cooler parts of the test tube. What are these colorless liquids? What are these colorless liquid droplets? They are for the water of crystallization lost when a group 1 carbonate is heated. The equation is sodium carbonate dot 10H2O to form sodium carbonate and 10 molecules of water. Sodium carbonate dot 10H2O has water of crystallization. it is a white it is white crystals, but sodium carbonate in itself without water of crystallization is only a white powder. So white solid changes to white powder and colorless liquid droplets formed on the cooler parts of the test tube. Group 2 and other valency 2 carbonates such as zinc carbonate, barium carbonate, lead carbonate, magnesium carbonate, they all decompose to give an oxide and carbon 4 oxide. Equation being magnesium carbonate decomposes to form magnesium oxide and carbon 4 oxide. Now note, some carbonates such as aluminium carbonate aluminium carbonate and iron 3 carbonate do not exist. Why do these two carbonates not exist? This is because they hydrolyze in moisture. They hydrolyze in moisture. Ammonium carbonate does not give ammonium oxide, it gives ammonia gas, carbon dioxide and water. So what is the observation when, let's say, zinc carbonate decomposes to give zinc oxide and carbon dioxide? The carbon dioxide changes lime water or calcium hydroxide to a white precipitate. CO2 changes lime water, which is calcium hydroxide, to a white precipitate. This is the observation when group 2 or valency 2 carbonates are heated. Effect of heat on sulfates. Group 1 and group 2 sulfates are also stable. However, they are even more stable than carbonates and nitrates, hence they do not decompose. However, the sulfates of heavy metals such as copper and iron decompose to give an oxide and sulfur 6 oxide gas. Sulfur 6 oxide is sulfur valency 6, oxygen valency 2, 2 to 6, S 2O6, 2 1, 2 3. So this is SO3. Sulfur 6 oxide is SO3. So copper 2 sulfate decomposes when strongly heated to form copper 2 oxide and sulfur 6 oxide gas. Effect of heat on hydrogen carbonates. Most hydrogen carbonates do not exist in solid state except group 1. So hydrogen carbonates group 1 hydrogen carbonate such as sodium hydrogen carbonate decomposes to give sodium carbonate, to give the carbonate, carbon dioxide and water to form sodium carbonate plus carbon dioxide plus water. Another example is potassium hydrogen carbonate. Potassium hydrogen carbonate decomposes to give potassium carbonate plus carbon dioxide plus water. So most hydrogen carbonates are not in solid state. However, the ones that exist in solid form are the group 1 and they decompose to give carbonate, carbon dioxide and water. Our next topic is application of solubility of salts, and the first application is separation of mixtures. So separation of mixtures depends mainly on whether a salt is soluble or insoluble in water, and it also depends whether it sublimes or it does not sublime. So for example, we have a mixture of zinc carbonate and sodium carbonate. Separate this mixture to get solid samples of each. How do you get solid samples of each from this mixture? 1. You first realize that all carbonates are insoluble except group 1 and ammonium, which are soluble. So group 1 carbonate, this is a soluble carbonate. However, zinc carbonate is an insoluble carbonate. So which method are you directly using? Over here you are using filtration method. So you will dissolve the mixture, dissolve the solid mixture in water. Dissolve the mixture or add cold distilled water. You can just say add distilled water to the mixture in a test tube. This dissolves zinc carbonate, sodium carbonate. Sodium carbonate dissolves to form sodium carbonate solution. Then you filter the mixture to get zinc carbonate residue and sodium carbonate filtrate. Wash the residue with distilled water. Wash residue with distilled water. With distilled water and dry it between two filter papers. So what have I done here? I dissolved the mixture in water so that sodium carbonate dissolves to form sodium carbonate solution. Now in this mixture we have a residue and a filtrate. So when you filter, zinc carbonate remains as a solid because it does not dissolve, it is a residue, while sodium carbonate is a filtrate, so it remains in the beaker when you filter. When you filter, you get zinc carbonate residue, which the residue now you will wash it with distilled water. What is the purpose of washing with distilled water? To remove traces of sodium carbonate. So once you wash with distilled water and you place it between two filter papers and dry it to get solid zinc carbonate, what do you do with the filtrate? You heat the filtrate up to saturation and cool to get crystals. As you wash the residue with distilled water and dry it between two filter papers, you heat the filtrate up to saturation and cool it to get crystals. So you will get solid sodium carbonate through this method and solid zinc carbonate through this method. Now please note, for any residue, for you to obtain solid crystals or solid of any residue, the last sentence in your answer must be wash the residue with distilled water and dry it between two filter papers. For any filtrate, for any soluble salt, your last sentence in the separation of mixture should be heat the filtrate up to saturation and cool to get crystals. Are we clear? Your last sentence in the separation of mixture, let's say you have said add distilled water to the mixture in a test tube to dissolve sodium carbonate. Sodium carbonate dissolves, filter the mixture to get zinc carbonate residue and sodium carbonate filtrate. This does not end your answer. You have been told to get solids. So how do you get the solid? You wash the residue with distilled water and you dry it between two filter papers. You heat the filtrate up to saturation and cool it to get crystals. For solids that sublime, we know the iron trichloride, aluminium chloride, ammonium chloride, benzoic acid, solid carbon dioxide, which is also called dry ice. So describe how solid samples of each can be obtained from a mixture of sodium chloride, ammonium chloride and silver chloride. Now when you get a mixture, what do you see? You see the properties of the salt. So in this case, we have sodium chloride which is soluble, we have ammonium chloride which sublimes, and we have silver chloride which is insoluble. We said all chlorides are soluble except lead chloride and silver chloride which are insoluble. So silver chloride is insoluble in water. How do you separate a mixture of A soluble substance, a substance that sublimes, and an insoluble substance. 1. You put the mixture in a beaker and cover it with a watch glass containing cold water. Then you heat the mixture. When you heat it, the solid that sublimes will sublime to form vapor, and then when that vapor goes up, it cools on the cooler parts of the watch glass. It cools to form solid. So in this case, put the mixture in a beaker and cover it with a watch glass containing cold water, that is half a mug. Heat the mixture. Ammonium chloride sublimes and forms on the cooler parts of the watch glass. Ammonium chloride has sublimed. What are you left with? You are left with sodium chloride and silver chloride. These two do not sublime, so they are yet in the mixture. To the remaining mixture in a test tube, add distilled water and stir to dissolve sodium chloride. Why are you stirring? To dissolve sodium chloride. So once you have dissolved sodium chloride, you got sodium chloride solution, but silver chloride did not dissolve. Now when you have a substance that has dissolved and one has not dissolved, directly filtration occurs. So when you filter, you get sodium chloride solution, sodium chloride filtrate, and silver chloride residue. What do you do to the residue? What is the last part? What do you do to the residue? You wash the residue with distilled water and dry it between two filter papers. What do you do to the filtrate? You heat the filtrate up to saturation and cool to get crystals. So if this question comes in your exam, how do you explain it? 1. Put the mixture in a beaker, cover it with a watch glass, heat. Ammonium chloride sublimes and forms on the cooler part of the watch glass. What are you left with? Sodium chloride and silver chloride. To the remaining mixture in a beaker or in a test tube, add distilled water and stir to dissolve sodium chloride. Filter the mixture to get sodium chloride solution and silver chloride residue. Heat the residue. Wash the residue with distilled water and dry it between two filter papers, and heat the filtrate up to saturation and cool to get crystals. You get your 3 marks. This is how the salts are separated. One, it is through filtration, and another one is when one of the salts sublimes, you put it in a watch glass and you cover it. How is the diagram of the watch glass, of the beaker with the watch glass? So let's just brief over here. You have a beaker, you cover it with a watch glass and you heat it from below. You have the mixture over here. The watch glass has cold water. So this is a watch glass with cold water, this is the beaker, and this is the mixture. This is heat. So the solid that forms here is the solid that sublimes. This is how salts that sublime are separated from mixtures, and others are looked at solubility and insolubility and are filtered accordingly. Our second last part is how we will make some salts. So let's look at how some salts are made. So we are looking at more examples of direct synthesis of precipitation or double decomposition. We are looking at more examples of direct precipitation or double decomposition. So for example, preparation of lead 2 chloride starting with lead 2 nitrate. So what are you preparing over here? You are preparing lead 2 chloride, which is an insoluble salt. What are you starting with? A lead 2 nitrate, which is a soluble salt. So we say that double decomposition requires two soluble salts reacting to form a soluble salt and an insoluble salt. So you have a lead 2 nitrate solid, but you cannot react a solid directly. You must make it a solution. You must dissolve in water. A solid cannot react directly with another solid or a solution. You must make it a solution. So dissolve lead nitrate solid in water to get lead nitrate solution. To it, add potassium chloride solution. Filter to get lead chloride residue. Now lead chloride is insoluble, isn't it? So when you filter, you get lead 2 chloride residue and potassium nitrate filtrate. But now you are not looking for the filtrate. You are not looking for the filtrate. You are looking for the residue, lead 2 chloride. So you wash the residue with distilled water and dry it between two filter papers. We explain it again. You have been given lead 2 nitrate, but you have been told to prepare lead 2 chloride. Now you are using precipitation method. Two soluble salts react to form a soluble salt and an insoluble salt. So you will dissolve the soluble salt in water to form a solution. You will get another soluble salt but with a chloride in it, which is potassium chloride or sodium chloride or magnesium chloride, whatever it is, but it is a soluble chloride. So that this chloride reacts with lead to form lead chloride, and this potassium exchanges the ion with nitrate to form potassium nitrate. Another example is preparation of lead 2 carbonate. Starting with lead 2 carbonate, describe how to prepare lead 2 sulfate. Starting with lead 2 carbonate. So, starting with lead 2 carbonate, preparation of lead 2 sulfate. So how do you prepare lead 2 sulfate? Starting with lead carbonate. Note, this salt is insoluble and this salt is also insoluble. You are preparing an insoluble salt, but you already have an insoluble salt. Now you need to make this insoluble salt to a soluble salt. How do you do it? You react this salt, you react lead carbonate with excess dilute nitric 5 acid. To get lead 2 nitrate solution. So you have gotten a soluble solution, a soluble salt, isn't it? Now to prepare through double decomposition, you need 2 soluble salts to prepare a soluble salt and an insoluble salt. However, when you already have an insoluble salt, you must make it to a soluble one. So you add excess dilute nitric 5 acid. What is the reason for excess? So that all the lead carbonate dissolves. The reason for excess dilute nitric 5 acid is so that all the lead carbonate dissolves to form lead 2 nitrate solution. Now to this lead 2 nitrate solution is when you use double decomposition. So you get another soluble salt, but when it exchanges ions, it will form insoluble and a soluble salt. So lead nitrate will react with a sulfate to form lead sulfate. So lead nitrate PbNO3 will react with a sulfate, a soluble sulfate to form lead sulfate. With soluble sulfate, you can say sodium sulfate. So react to the mixture, to the solution, to the lead 2 nitrate solution, add sodium sulfate solution. To this solution, to the lead nitrate solution, add sodium sulfate solution. Then you filter. When you filter, what do you get? Sodium goes with nitrate to form sodium nitrate. Filter to get sodium nitrate filtrate. Sodium nitrate filtrate. And sulfate goes with lead and lead 2 sulfate residue. Then you wash the residue with distilled water and write between 2 filter papers. The filtrate, you heat it up to saturation and cool to get crystals. What have we learned? When you have an insoluble salt and you've been told to prepare another insoluble salt, you must make the insoluble salt that you have to a soluble one, so that that soluble salt reacts with another soluble salt to form a soluble salt and an insoluble salt. For example, lead carbonate here is insoluble, isn't it? But lead sulfate is also insoluble. You need to make this salt into a soluble salt. How? You react excess dilute nitric 5 acid. If you dissolve it in water, it will still remain insoluble, it will not dissolve in water, and hence it will not react with another salt. This salt you cannot dissolve in water and expect it to react because it is already insoluble. So when you react it with dilute nitric 5 acid excess, it reacts completely to form lead nitrate. Then that lead nitrate is soluble, you use it with a soluble sulfate, you react the two and you filter to get a soluble salt and an insoluble salt. Preparation of oxides. When you have been told to prepare an insoluble salt, but they have given you an insoluble salt, react that insoluble salt you have been given with dilute nitric 5 acid. Do not dissolve it in water, otherwise you will lose your mark. You will lose your marks, because even if dissolved in water, that salt will not be able to react. Hence, there is nothing you are forming. You are just wasting your time. Preparation of oxides. Describe how to prepare magnesium oxide. I won't write everything. So magnesium oxide preparation starting with magnesium chloride solid. So how do you prepare an oxide of group 2? An oxide of group 2, you know that the carbonate when heated, let's say magnesium carbonate when heated, it forms magnesium oxide and carbon dioxide. So this is how you will form the oxide, by heating magnesium carbonate. So what do you need to get here? Magnesium carbonate. So when you get magnesium carbonate, when you heat it, it forms magnesium oxide. So in this process, what are you looking to form? You're looking to form magnesium carbonate. So dissolve magnesium in water, magnesium chloride in water to form magnesium chloride solution. You are starting with magnesium chloride solid, isn't it? So dissolve magnesium chloride solution in water, magnesium chloride solid in water to form magnesium chloride solution. To the solution, add sodium carbonate. Filter to get magnesium carbonate residue. Wash the residue in distilled water and dry it between two filter papers. Wash the residue and dry it between two filter papers. Now when you have gotten the residue, you heat the residue. To decompose magnesium carbonate to form magnesium oxide. We repeat, preparation of magnesium oxide starting with magnesium chloride. How will you prepare magnesium oxide? You will not directly prepare it. You will first prepare magnesium carbonate, then decompose that carbonate to form magnesium oxide. How do you start? Magnesium chloride is soluble. So when you get a solid and it is soluble in water, what is the first thing you do? You dissolve it in water to get a solution. You cannot react a solid directly, you must dissolve it in water. So when it is soluble, it is easy for you. You just dissolve it in water to form magnesium chloride solution. Now you have a soluble salt. You need another soluble salt, but with this ion, with carbonate ion. So most likely you can use group 1, so sodium carbonate. React to it, add sodium carbonate solution. Add sodium carbonate solution. So when sodium carbonate is added to magnesium chloride, sodium takes chloride and magnesium takes carbonate. So when you filter, magnesium carbonate is insoluble. All carbonates are insoluble except group 1 and ammonium. Magnesium carbonate is insoluble. So when you filter, you get magnesium carbonate residue. Now do away with the filtrate. You are not using the filtrate, so don't mention it again. Deal with the residue. Wash the residue with distilled water and dry it between two filter papers to get magnesium carbonate solid. When you have gotten magnesium carbonate solid, heat it to decompose to form magnesium oxide. Are we clear? I have one more example which I'll just explain. I won't write too much. Preparation of copper 2 carbonate starting with copper metal. So copper metal, preparation of copper metal to prepare copper 2 carbonate. How do you prepare copper metal to form, react copper metal to form copper 2 carbonate? I mean, how do you prepare copper 2 carbonate starting with copper metal? How do you start? You heat the copper in air, heat copper metal in air to form copper 2 oxide. Now we saw copper 2 oxide is insoluble, isn't it? It does not dissolve in water. So when a salt is insoluble and you are asked it to prepare another salt from it, a salt is insoluble and you are asked to prepare another salt from it. You will react it with dilute nitric 5 acid, excess dilute HNO3 to form the metal nitrate. You will not dissolve it in water because it is insoluble. So, heat copper metal in air to form copper 2 oxide. Add excess copper 2 oxide to dilute nitric 5 acid to form. What does copper 2 oxide when react with HNO3 form copper 2 nitrate? To form copper 2 nitrate solution. Copper 2 nitrate solution. Isn't it? To this copper 2 nitrate solution, now you have got a soluble solution, a solution. You've got a soluble salt. You need another soluble salt. But what are you preparing? You are preparing copper 2 carbonate. So you need a soluble carbonate, which is sodium carbonate or potassium carbonate. So add sodium carbonate solution. Filter the mixture. When you filter, what do you get? Sodium goes with nitrate to form sodium nitrate. Filter the mixture to get sodium nitrate filtrate. And potassium carbonate residue. No, and copper carbonate residue, copper 2 carbonate residue. But you've been asked for the residue, isn't it? Copper 2 carbonate. There is no way you've been asked to prepare the filtrate, so you leave the filtrate alone. You wash the residue with distilled water and dry it between two filter papers. Your work is done. When you have an insoluble salt and you have been told to prepare a soluble salt, the insoluble salt you react it with dilute nitric 5 acid to form the nitrate, and then react it with another soluble salt, filter to get a soluble salt and an insoluble salt. Our last part is uses of salts. We have come to the now before uses of salts we have the three types of salts. So properties of salts, this is the last part before the uses of the salts. We have one, deliquescent. What is deliquescent? Deliquescent salt is a salt that absorbs moisture from the atmosphere to form a solution. And examples of deliquescent salts are anhydrous calcium chloride, aluminium chloride, and anhydrous iron 3 chloride. Anhydrous means that it lacks water, it does not have water. So when it absorbs the moisture from the atmosphere, it forms a solution. It forms aluminium chloride solution and iron 3 chloride solution. So this is deliquescent. Now what is deliquescence? Deliquescence is the process by which a salt absorbs moisture from the atmosphere to form a solution. So deliquescence is the process by which a salt absorbs moisture from the atmosphere to form a solution. The second one is hygroscopic. Hygroscopic is where a salt absorbs moisture from the solution, but from the atmosphere. Hygroscopic is where a salt absorbs moisture from the atmosphere but does not form a solution. They become damp. Examples are anhydrous copper 2 sulfate and anhydrous cobalt 2 chloride. So they become powdery. Hygroscopic salts become powdery when they lose water. No, this becomes powdery. Efflorescent are the ones that become powdery. Hygroscopic become damp. When they gain moisture from the atmosphere, they become damp and they change color. Such as anhydrous copper 2 sulfate changes from white to blue, and anhydrous cobalt 2 chloride changes from blue to pink. So when without water, it is white powder. But when with water, it is blue crystals. Efflorescent. These are salts that lose water of crystallization to the atmosphere. Where deliquescent and hygroscopic gain water from the atmosphere, efflorescent lose water of crystallization to the atmosphere, and they become powdery. Hydrated examples are hydrated sodium carbonate and hydrated copper 2 sulfate. So sodium carbonate loses water of crystallization in the equation shown below. Hydrated copper 2 sulfate is efflorescent because it loses water of crystallization. However, anhydrous copper 2 sulfate is hygroscopic because it gains moisture from the atmosphere. Efflorescence is the process by which salts lose water crystallization to the atmosphere. Hygroscopy is the process by which salts absorb moisture and do not form solutions. Our last part is uses of salts, and I will just read some of the uses of salts to you, which you can write them down. One, sodium chloride is used as a food additive that we know. We have even talked about that before. Food additive. We have so many salts, but we cannot give all the examples, so we will just choose a few. Ammonium chloride is used as a nitrogenous fertilizer. Ammonium chloride, nitrogenous fertilizer. And explosives, used to make explosives, ammonium chloride. Another one is magnesium oxide is used to line furnaces. Magnesium oxide used to line furnaces, to coat furnaces due to very high melting point. Sodium carbonate is used to soften hard water. And the last use that I will mention is silver bromide is used in photography. Silver bromide. If you know how it's written, how is it written? Silver Ag, bromine Br, valency 1, cross. So silver bromide is AgBr, is used in photography. So there are other uses of salts, but these are the ones which I will mention. And with that brings us to the end of a very long topic. Thank you all for watching. I hope you have understood, and areas that have not been understood, if you have any questions in this topic, please kindly feel free to drop in the comment box, and I will tackle all your questions, answer them appropriately. Until the next lesson, goodbye, take care, thank you for watching.